Have you ever looked at an AI and wondered, is it really smart or is it just kind of lucky at guessing? Well, today, we're going to pull back the curtain on a technique that's like a detective's magnifying glass for AI. It helps us figure out not just what a model can do, but how, and maybe most importantly, why it does it. You know, we have these incredibly powerful AI models, right? But so often, they feel like a total black box. You put data in one end, an answer pops out the other, but the logic, the reasoning happening inside can be a complete mystery. So how on earth do you peek inside that box and see what's actually going on? And that's the real challenge here. We're building these tools that are literally changing our world, but sometimes even the brilliant people who make them can't fully explain the why behind their decisions. So we need a way to investigate, to understand those inner workings. And that is exactly what this explainer is all about. So the key to cracking open that black box, it's a surprisingly simple but really powerful idea. It's all based on the power of removal. The technique is called an ablation study. Think of it like this. An ablation study is basically the science and engineering version of playing Jenga. You carefully, strategically pull out one block, one single component of the AI model, and then you step back and see if the tower wobbles or if it stays standing. It's a super simple but powerful way to test what each piece is actually doing. The whole process is just brilliantly straightforward. You start with your complete model, right? It's got all its features, A, B, X, the whole shebang. Then you create what's called an ablated version, where you've just taken one of those features out. The entire investigation just comes down to comparing the performance of the two. And this right here is the fundamental idea. If you take a piece away and suddenly the model gets a lot worse at its job, well, congratulations, you've just found a really, really important component. That piece was obviously doing some serious heavy lifting. So, okay, why go through all this trouble? What's the real payoff for playing detective with our AI models? Well, it turns out the insights you get are incredibly valuable, and the payoff is huge. First, you can pinpoint exactly which features are doing the real work. That directly helps explain the model's reasoning, making it less of a black box. You can also check for robustness, making sure the AI isn't just, cheating by relying on one weird data point. You can even make the model more efficient by trimming away the useless parts. And for researchers, it provides real scientific validation that their new idea is actually working. So, how's it actually done? Well, conducting an ablation study isn't some chaotic process. It's more like following a clear 5-step recipe, a structured investigation designed to give you clear answers. The whole process just flows so logically. You start by defining your goal. What question are you actually trying to answer? Then, and this is key, you measure your full model to get a baseline score. From there, it's just a cycle. You remove one piece, you test it again, and you compare that new score to your baseline. And that last step, step 5, that's where the magic happens. You interpret what those changes really mean. Now, out of all those steps, I'd argue that establishing that baseline is the most critical one. Without that starting point, say a model with 92% accuracy, all your other results are basically meaningless. I mean, a performance drop to 80% doesn't tell you anything if you don't know where you started from. And this is where the story really comes together visually. Look at this. Our baseline model is humming along at 92% accuracy. But whoa, when we take out feature X, performance plummets all the way down to 80%. That is a huge signal. Then we try taking out feature Y instead, and the accuracy barely even budges. That massive difference between those two results is where all the insight is. So now we interpret. That huge drop when we removed feature X, that tells us it's a critical feature. That tiny little dip from removing feature Y, it suggests that feature is probably redundant, or at least not very important. And hey, sometimes you get results that are just plain weird, which can point you toward deeper, totally unexpected issues in your model or your data. But when you zoom out, this whole process is about something much, much bigger than just nudging a performance score up by a percentage point. It's really about a fundamental shift in what our goal is. This quote really gets to the absolute heart of it. A high accuracy score is great, we all want that. But it's not enough. If you don't know why it's accurate, can you really trust it? Can you make it better? Can you be sure it's reliable and fair? The real prize isn't just performance, it's genuine understanding. When it comes right down to it, ablation studies force us to shift our focus away from just what a model can do and toward why it can do it. It's the difference between having a magic box that works for reasons you don't understand and being the magician who actually knows how the trick is done. And that leaves us with one final thought to chew on. As these AI systems get more and more complex and more woven into our daily lives, in our medicine, our finances, everything, what is the real cost of not knowing why they make the decisions they do? What are the risks we're taking by treating them as black boxes we can't explain?